All right, everybody, we have our first set of notes. These are going to be called Intro to Balancing Chemical Equations. So we have different ways we represent chemical equations. You don't have to write this down, but we've already done symbol equations. So sodium plus chlorine makes salt. That would be a symbol equation. We also have done word equations. So sodium plus chlorine makes salt. And then we could also make a whole sentence. So sodium combines with, etc., etc. There's actually a fourth way, and it's called a balanced chemical equation. So what we do here is we actually look at the very first chemical equation we have, the symbol equation, and what we do is we change it so that we have the same amount of each atom on both sides of the arrow. So our arrow is like an equal sign. We're going to use this example here, and we're going to learn how to balance chemical equation. Now, I've gone ahead and written that same equation here on this whiteboard. Now, we need to figure out how to balance this equation. Something that can help us is relying on our prior knowledge. If we recall, we can build this exact thing. So sodium would be a single gray ball. Cl2, that little 2 means they're bonded together. And then Na and Cl, because they're written next to each other, they should be bonded together. So we have our 3 compounds here. And what we want to do is we want to have the same amount of each atom on both sides of the arrow. We want to have the same amount of green ones, the same amount of gray ones, and the same amount, that's it, just green and gray. So if we look here, we have 1 gray here, 1 gray here. So the sodium is good. But if I look here, I only have 1 green one, but up here I have 2 because of the 2 that's right here. So this isn't going to work for us. We need to have another green one. And I can't just add a green one just because. I can't just throw in a green one right here, because that's not the same thing. This isn't the same as this. And we need this NaCl. We need salt. This is chlorine, not salt. We want the whole thing. So I can't just add one. I have to add the entire compound. I would have to build a whole nother one of these. When I do that, this, because we have 2 molecules here, becomes a big 2 in the front. This is called a coefficient, if you don't remember. Let's see if I can write that. Coefficient. That tells us how many molecules we have. So, coming back over here, instead of having 1 chlorine, we now have 2. We have 2 green ones over here. Now that fixes our green one problem, right? We have 2 greens on this side, and we match with the 2 greens on this side. But when we did that, when we put the 2 in front here, we didn't just change how many green ones we have. We also changed how many gray ones we have, the NAs. Now we have 2. So this side doesn't match this anymore. So when we double this one, we also need to double this one. I'm going to need another one of those. When I do that, now we have 2 atoms, but we also have 2 molecules here. We have 2 sodium. 2 sodium. Boop. So in order for this equation to have the same amount of each color on both sides, we're going to have 2 of that one, 1 of this one, and 2 of that one, which is trying to roll away. This is what we would call a balanced chemical equation, the same amount of each atom on both sides of our arrow. We've seen this before and we've done this before, although you might not remember it that well because it was a while ago, but we actually balanced a bunch of different equations, or we built equations so that they were balanced. So we have this one here. It's the same one I just did on the board over there. We have 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. So this one's balanced. We could also see something similar here. 1 magnesium, 1 magnesium. 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen. We could do it with all of them. So this is your goal. Your goal is to create these balance equations, not just have them given to you, but to make them all. To make balanced chemical equations, we need to change the coefficient, or how many molecules we have, in order to get the same amount of each atom equal on both sides of the arrow. We can do that by using a RIP table or a RAP table. So R, you can use A or I, I'm going to use I, RIP. So it's set up something like this. The R stands for reactants, the P stands for products, and then the I stands for individual atom, or if you put A, stands for atom. This would be like sodium, oxygen, chlorine. Notice how there's no numbers in the front or on the bottom here. We're just writing down the element. We're not writing down a formula or a molecule, just an atom. Now we can use this to help us identify how many of each atom we have on both sides of a chemical equation. For example, let's go ahead and say I wanted to make sodium oxide. Sodium reacts with oxygen gas in the air to make sodium oxide. Now, the formula, the ionic formula for sodium oxide, oxygen has a charge of 2, sodium has a charge of 1, cross them over, we get Na2O1. So before we can even start balancing, we have to make sure we have the right equation with the right formulas. Sodium's a solid metal, it doesn't get a number. Oxygen is one of our diatomic elements, so it needs a 2. And then the correct formula for the ionic compound sodium oxide is found by swapping those charges, so Na2O. Now that we have the right whole equation, we can start balancing it. So let's write down every atom we have, every individual element. We have sodium and we have oxygen. Now we're going to count how many of each element we have on both sides of our arrow. Our arrow is right here, so we're looking on either side. On the reactant side, on this side, we have 1 sodium right here. So I'm going to write 1 right there. On this side, our product side, we have a little 2 right here. That means we have 2 sodium. So that's not balanced. We'll have to fix that in a minute. Oxygen here, if I count that up, we have 2, and that's coming from the 2 right here. So 2 oxygen on this side. On this side, there's nothing written next to the O. So that means there's only 1. So we have kind of a crosshair problem here, where we have the right opposites of everything we need. Now your first instinct might be, oh, just subtract 1. You can't do that. We can only use coefficients. We can only change how many of each molecule we have. If I were to draw this out, O2, because that's a little 2, O2 looks like this. I can't just get rid of that. It's not the same thing. The only thing I can do is have more of this or less of this whole thing, the whole molecule. Same thing over here, Na2O. That's going to be 2 sodiums and 1 oxygen, all connected together. 2 sodiums, 1 oxygen. I can't just get rid of the oxygen here, because then it wouldn't be the same thing. We have to make sure that we're making or destroying whole molecules, the whole thing here. So let's go ahead and try to do the sodium first, since it's written first here. We have 2 on this side and only 1 over here. If I drew that, it would just be 1 circle. So what I can do is I can get another one of this thing right here. I can make another. If I make another of that, that's another molecule. And the coefficient tells us how many molecules there are. So now we have 2 sodiums. I'm not going to put the 2 down here like this. That would be wrong. That would be if they were connected, which they're not. These are separate, which means the 2 is going in front. Again, we can only use coefficients to fix these equations. So if I put a 2 in front here, that's the same as multiplying by 2 up here. These are the same thing. Now we have 2 sodium on this side, and we have 2 sodium on this side. So currently, our sodium is balanced. We successfully fixed sodium. We need to do the same thing with oxygen. If we look at oxygen, we have the 2 here, and then we have 1 here. Again, we have to make more molecules. I can't just add another circle like that. That's not going to work. Instead, I need to have the whole thing. So I can make another one of these molecules. If I do that, that's the same as putting a big 2 in the front right here, a coefficient of 2. And this is the same as multiplying by 2 here. Now the problem, I just wrote 2 twice here. That's because we didn't just multiply the oxygen by 2. This 2 is going in front of the whole thing. It's not going in the middle, that's not allowed. It's telling us we have 2 of this whole molecule. I didn't just draw more oxygen right here. I drew more oxygen and more sodium. I multiplied by oxygen and I multiplied by sodium. We can see that math if we count it out. We started with just 2 sodium. What's 2 times 2? 4. 1, 2, 3, 4. So that's where this is coming from. Same thing with oxygen. We started with just the 1 oxygen here. 2 times 1 is 2. 1, 2. So putting the 2 in front multiplies everything after the 2. That puts this one up to 2. We have 2 oxygen on this side now. We also have 2 oxygen on this side, so this is looking good. But we messed up the one we just did. Now we have 4 sodium on this side, 4 orange ones here, and we only have 2 over here. So we're gonna have to go back to what we did, and we're gonna have to change it. We're gonna have to update it. So oxygen's fine, sodium needs some work. We have 4 on this side. We need to make 4 on this side. What we can do is we are the ones who put this here in the first place. We are the ones who added this. It wasn't there until we did that. What we can do is we can change it. We don't have to keep it the same as we had it. Instead of just drawing 1 more sodium, I could draw as many as I need to make this work. So if I need 4 sodium, I can draw 4 sodium. If I have 4 unconnected sodiums right here, that's the same as having a big 4 in the front right here. And that's the same as multiplying by 4. What's 1 times 4? 4. We have 4 on this side, 4 on that side, 2 on this side, 2 on that side. With that, we are now balanced. Whew. I'm going to write the equation a little bit easier off to the side over here. We have 4 Na plus O2 turns into 2 Na2O. Whew. That was a lot of work. This is what a RIP table is. This is how we solve these questions. We look at each atom individually. We multiply until we get the same numbers on both sides. And then we double, triple check, quadruple check it's balanced. And then we write out the final answer over here. And that's it. If this isn't intuitive to you, I would encourage you to draw out what you see or use the modeling kits to help you. If this is intuitive to you, I would encourage you not to use this table. I would encourage you to look at the equation as you see it and work from there. Let's see another way of solving this. I'm going to erase this whole RIP table and let's try solving it another way. Same equation, sodium plus oxygen makes sodium oxide. Oh, I forgot the A. Another way we can solve this is by just writing the numbers on the top and bottoms of the equation. So, same thing, sodium, if I look over here, I have 1, over here I have 2. My first thought would be to put a 2 here. Now this is up to 2. Next we look at oxygen. We have 1 over here, 2 over there. First thought is to put a 2 here, but that changes this up to 2 and this up to 4. Then we'd have to come back over here change this to 4. If you look at it that way and that makes more sense to you, do it like that. You don't have to make the whole table if that thing's confusing to you. If this makes more sense, do it this way. If the other way made more sense, do it that way. If it makes more sense for you to write it out on either side and go, okay, NA equals 4, NA equals 4, do it that way. I know some people who they write a list off to the side of every element and then they write out these like long equations. So they write like NaO equals 1 equals 2, and then they do it here and they do it here. And then they multiply like this. And for that, it works for them. I want you guys to think about what makes the most sense to you and do it that way. If you need a lot more support, do the table. If you don't need as much support, do it the other way. If this makes more sense, do it this way. It's literally all up to you. If drawing it helps, do that. If just looking at the numbers helps, do that. If coloring helps, do that. This is very much a concept that you need to figure out how it best relates to you. How are you better able to digest that information? This is going to require some practice. So right now, your practice is going to be to do a simulation, a PhET lab. We've done those before. There's a link inside of our class notebook. I want everyone to mess around with the simulation until you feel confident in your abilities. I don't want you to skip ahead and do the quiz because you think that's going to help. I want everyone to mess around with this until they're feeling really good about how to make it work, okay? If you have questions about this, you need more help in class, please ask me. It's a weird concept. It does weird things, and I get that. So, that's the summary for Intro to Balancing. We'll talk more about this next week or after break.